We continue with our discussion on differential equations and the different types that we possibly come across. The next method is linear equations. Now, in this type of differential equation, this is an equation which has this particular form. dy dx plus px times y is equal to q of x. Now, let's just analyze that first. Dy dx is obviously our derivative. P of x is some function with respect to x, and likewise q of x. And they do not necessarily have to be or have to contain an x. It could be a constant. Like for p of x, I could have 5 times y. Then p of x would be 5. It simply does not contain the x. Well, it does contain x as x to the power 0. Nonetheless, the first thing that you have to do with a particular equation is identify that this is a linear form. And this particular variable there, y, that will give you an idea that we're dealing with a linear equation. Now, we'll get to one example. However, I just want to provide the background to the steps that we are going to follow. So when we have an equation of this form, what we tend to do is we introduce what we call an integrating factor. Okay, that's one I. And I'm going to call that if. Now, textbooks may use a different name, but generally they refer to that as a integrating factor. And what is this integrating factor? It's e to the exponent. So in the exponent, you actually have an integral. Just to emphasize, it's e. So my integrating factor is e to the integral p of x dx. So that is actually the exponent of the base e. So we take that integrating factor and multiply every term that you see there by the integrating factor. So it will be e to the power p dx times dy dx times pxy times q of x. So I took the equation 1 and multiplied every single term by e to the integral p of x dx. Now, to make it easier, I've written that as if. So there's if, there's if. My integrating factor, which of course is e to the power integral of px dx. Now, these terms, if you look at it very carefully, is actually a product rule in reverse. It is the product rule of the function I of f, y. In other words, if I find the derivative of an integrating factor times y, I will get this particular answer, where I leave the integrating factor, find dy dx plus, then I leave the integrating factor, I leave the y, and then I find the integrating factor times. It's by the implicit differentiation, I will get that. Now, in order to eliminate d by dx, I integrate both sides. And recall, watch this very carefully. You know what the integral of dy dx is. You know how to find it. What then is the integral of dy? Or what is the integral? In other words, what I'm trying to emphasize here is let's just re-erase that. We've already come across this before. What is the integral of dy? That is simply y. What is the integral of dx? That is simply x. The integral of a derivative is simply the function itself. So yeah, if I integrate both sides, I find that the function is my integrating factor times y, and I integrate the right-hand side, I get the integral of the integrating factor times q of x dx. Now at this stage, I can placate you to a certain extent. You don't really need to know that part there. That is obtained, that is used to obtain equation number 5, which is what you are going to use. So in our differential equations, we have in essence 3 important steps. Firstly, we identify that it's a linear form. Then the next step, we find the integrating factor. And then the last step, we simply substitute the integrating factor into this equation and work it out. I prefer doing this to provide the mathematical theory behind the steps in the procedure that we are going to implement. You'll notice in my notes of lessons, I have not done that there. We looked at examples only. So let's recap. A differential equation. Get the form correct, find the integrating factor, substitute into this equation, and then work that out. Now, I'm only going to do one example because we have many examples on the notes of lessons. So let's look at this. Solve the differential equation x dy dx minus y is equal to x cubed cos of x. Given that f of pi is equal to 0. Now, how would we know that it's not separating variables? Look very carefully. No matter what we try and do, by like, for instance, transposing the y, let's say I do this, x dy dx, and transpose the y plus x cubed. No matter what I try and do, even if I try and take dx up, I won't be able to separate dy's and dx's on either side. In other words, the previous technique of separating variables is not going to work. So we'll have to cross that out. Let's just erase that. I don't want to interfere in our working out. Okay. So what then do we do? Well, we go to the next strategy, the next method, which is linear equations, linear differential equations. So this is linear DEs. What's the form of a linear DE? That's step number 1. Let's go back. There's the form dy dx plus p of x. There's the form times y equal to q of x. So the form is dy dx plus some function with x times y is equal to q of x. Now let's look at this equation. Is that in the correct form? No, we need a 1 over here. And there's the x. So in my solution, step number 1 would be divide every term by x. So I get dy dx minus, now look carefully what I'm going to do. Instead of saying y over x, I said 1 over x times y, and of course x cubed over x. That will give me my x squared cos of x. So this reduces to dy dx minus 1 over x times y is equal to x squared cos of x. Now I hope you can see why I did not put the x as a denominator of the y, because there's my dy dx. Let me get another color, maybe you'll see that a little better. There's my dy dx, there you go. There's my y, there's the y, which means p of x is that part and q of x is that part. So this is p of x and this is q of x together with the sign. So there you go. You get to that stage where you have it in the correct form. Now, once you have that in the correct form, let's just recap. What do I do next? Find the integrating factor. What is the formula for the integrating factor? Therefore, my integrating factor is if equal to e to the integral p of x dx. Let's do that substitution immediately. Integral minus what's, make sure you take the negative as well, which is e to the minus integral 1 over x dx. And what is the integral of 1 over x? E to the minus ln of x plus c. Now, we won't put the c in there because we'll wait till the last step. Now, recall, can this be simplified further? Yes, it can, because the base of that exponent is e, and the base in the index ln, remember the base of ln is e as well, except that negative sign is a problem. We must first take that negative sign there before we can eliminate e and ln. In other words, that becomes e to the power ln x to the minus 1. And then we can say, because e and ln have the same base, my answer is x to the minus 1, and thus my integrating factor is equal to 1 over x. Right, so let's recap. This was, in essence, step number 1, getting the correct form. Step number 2 was finding the integrating factor. And what's step number 3 now? Let's just quickly recall. I simply use, okay, I've written step 2 there. I simply use this equation, integrating factor times y. So now I substitute into integrating factor times y is equal to the integral of the integrating factor times q of x dx. And that's all I have to do. What's my integrating factor? 1 over x times y. Integral, what's my integrating factor? 1 over x. What is my q of x? There you go. There's my q of x, x squared cos of x dx. So this simplifies to y over x is equal to the integral of x cos of x dx. Now I just have to work out the integral, and the integral is integral of x cos of x. Integral of x cos of x. Aish. That's right. Remember, with integration, any technique can be used. Any technique can crop up anywhere in your solutions, in your applications for integrations, areas, volumes. I can give you any technique. So how do we solve this? That's right. Do you recall? Integration by parts. So I'm going to call that equation number 1, and I'm going to work out my integration by parts separately. So let's go on to a new slide. So let's take integral of x cos of x dx. Do you remember? Integration by parts. Let's use u equal to x. Therefore, du is equal to the derivative of x is 1, and dv is equal to cos of x dx. Therefore, v is equal to sine of x. Now I use my formula uv minus integral v du. So this will be equal to x times v sine of x minus integral sine of x, and what's du? Dx. Just using that in the integration by parts. What is the integral of sine of x? Fortunately, that's a straightforward one. We don't have to use integration by parts. We don't have to use integration by partial fractions. It's not an integration using trig functions or even powers of sine and cosine. Be aware of all that can appear anywhere. The integral of sine is minus cosine. Minus times the minus gives me a plus cos of x. Now I'm going to substitute that into our previous equation that we have. Therefore, solution, let's just go back to remind you. I must substitute my answer in here where it says parts. So it's y over x equal to y over x is equal to x sine of x plus cos of x plus my constant c. So that is my general solution. Do we have initial conditions? Let's go back to the original problem. Yes, we do. F of pi equal to 0, y of pi, I should write pi, y. Nevertheless, x is equal to pi, y equal to 0. Do the substitution, 0 over pi is equal to pi times sine pi plus the cos of pi plus c, 0 over pi, 0, sine of pi, 0, cos of pi minus 1 plus c, c is equal to plus 1. Therefore, my solution to the differential equation is y over x equal to x sine of x plus cos of x, and substitute 1 into c plus 1. There is my particular solution that completes the problem. Look through all the other examples. Look through all the other examples that I have in my notes of lessons.